Good evening, everyone. So, welcome to my YouTube channel, Maths of Theorem. So, today we are going to see 10th lecture on sequence. Today we will study the continuous function theorem for sequences. So, what is continuous function theorem for sequences? The continuous function theorem for sequences. So, let A and be a convergent sequence and limit of an is limit of an is equal to f. If f is continuous at L and f is defined on an for all n belongs to n, then f an is also is also convergent is also convergent such that limit of f an is equal to f L. Okay, so let's prove this theorem. Let f is let f be continuous at L and f be defined on an for all n belongs to n. Let epsilon greater than 0. Since f is continuous at L, there exists delta greater than 0 such that f x minus f L less than epsilon for all x with x minus L less than delta. Okay. Let's say this is equation number. Now an is convergent with limit of an is equal to L. There exists capital N belongs to N such that an minus L less than delta for all n greater than capital N. Okay. Now from 1 and 2, from 1 and 2, we have f a n minus f l less than epsilon for all n greater than capital. So what is the meaning of this? The meaning of this is f a n is convergent and limit of this fn sequence is equal to fl. Okay, so this is proved. Okay, now example. So that the sequence this n plus 1 upon n is convergent and limit of this sequence n plus 1 upon n is actually 1. Okay, now what is the limit of this? There is a root. So what is the limit of n tending to infinity? N plus 1 upon n. So this is infinity upon infinity indeterminate. So we can write it. You take derivative using L'Hopital rule. This is 1 derivative of n and this is 1 by L'Hopital rule. Okay. So this is limit n tending to 1 upon 1. So limit n tending to infinity 1 is equal to 1. So this implies this sequence n plus 1 upon n is convergent and limit n tending to infinity n plus 1 upon n is equal to 1. Now define fx is equal to root x. Okay. Then f is continuous at 1 and f is also defined on so this function fx is equal to under root x we define then f is continuous at 1 and f is defined for all n plus 1 upon n for all n belongs to n. Then, so by Now, by continuous by the continuous function theorem for sequences, we get what we get limit of n tending to infinity f n plus 1 upon n is equal to f1. Okay, so what does it mean? It means that limit n tending to infinity. Okay, this implies therefore therefore this sequence is convergent and limit of n tending to infinity. This sequence is 1. So this is done. So today's lecture up to this, if you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you for next lecture.